Good morning, dear students. In the last class, we discussed about the exercise problems or questions. So, till fifth problem we did. So, now we need to do the sixth problem. From sixth, we need to do the remaining problems or the questions. So, here they gave that in the figure 8.11, shows the distance time graph of three objects A, B, and C. Study the graph and answer the following questions. Okay, so here first, which of the three is traveling the fastest? So here we have A, B, and C. So here three objects were there, which is starting from the initial position. So we need to tell which of these three are traveling fastest. So just look into this. So here it start from C. So it is all the objects are in the uniform motion. Why? Because it shows a straight line graph, isn't? So it's a uniform motion. So we need to say which of the following is traveling fastest. So in this we can say that, see, the B is traveling fastest. Why? Because if we see in the graph, it is shown to be less. So but when you see from the distance, from the zero it is traveling, so the distance traveled is more here. And when you see about this, what is it, C? So it is, so comparatively it not moving faster. Okay, so like this we need to identify. So our next question, second question, are all three ever at the same point on the road? No, isn't? So is all the 3 points, I mean all the three ever at the same point on the road, in the road, ever at the same point? No, only the A is here, C and B is meeting, and again here, what is that, A, B and C is meeting, and A and C is meeting, but all the three is not meeting at the same point. So therefore answer for this, never. No, it will not meet. And next one, how far has C traveled when B passes A? So this is one of the question. So how far? So you need to see here. So how far? See here, just look into this graph. This is the distance, 4 meter. This is 8 meters. In between this it is approximately, but we're not able to tell exact number, but we can say approximately. So it is around 6 kilometers, like that. So for answer for this is, so all of you write the answer like this. So first answer, what's the first answer? So B is traveling fastest as he is taking less time to cover more distance. Okay, next one, all three are never at the same point on the road. And so here, what is the how far C travel? So it's approximately here 6 kilometers. So here 4, and here it is 8, and 7 when we get here. So here around 6. So here it is around 6. And next one, how far has B traveled by the time passes C? Time passes C, how far the B travel? It is around approximately 7 kilometers. So these are approximate works. So this is a question. So write this graph in your classwork. So no need to do in the graph sheet. Take in the your classwork only, do this rough diagram. Rough diagram in the sense, no need to use a graph. So take the scale, pencil, and draw this, and no need to draw these lines and all. But just you write this 12, 8, 4, 0, and here 0 0.4, 0 0.8, 1.2, 1.6, all these things. Write this time and distance, and draw in your normal classwork only. And yeah, after writing the first question, write the first answer. Second question, second answer. Third question, third answer. Fourth question, fourth answer. Okay, okay. So then we move for the next problem. Okay, here the next question. A ball is gently dropped from a height of 20 meter. Okay, see here, this is some how something is this. So this is some building. Okay, it is 20-meter height. The height of this building is 20 meter. So a boy is standing at this point, and he drops a ball to the ground. This is a ground. Okay, a ball is gently dropped from a height of 20 meter. From this point, a ball is dropped. So ball is dropped from a height of 20 meter. if its velocity increases uniformly at the rate of 10 meter per second. See here, 10 meter per second square they give. Suppose they give here 10 meter per second, then it is velocity. So but a 10 meter per second square is there, then it is a acceleration. And height they given from here to here, the distance is nothing but s, that is that you can write that as a s, small capital letter S, that is 20 meter. If the velocity increases uniformly at the rate of 10 meter per second, with what velocity will it strike the ground? With what velocity will it strike the ground? Okay, at what velocity it will strike the ground, and after what time it will strike the ground. We need to find the time and also the final velocity. So what is initial velocity? Actually initial velocity is 0. Why? Because here the boy is standing at the top and he is holding the ball. When he is holding the ball is at rest. So ball is at rest, so the initial velocity is 0. But how much distance it traveled? It traveled a distance of 20 meters, isn't? So therefore we can write here initial velocity u is equal to 0, and final velocity we need to find, and also we need to find the time. So here we can write like this. So that is initial velocity, so what they gave is 0. Okay, initial velocity 0. So u is equal to 0 meter per second, s is 20 meters, and a 10 meter per second square, and v is, so that is we need to find final velocity that they asked after what time. So what velocity will strike the ground? That is nothing but final velocity. So at the beginning it is initial velocity, after reaching the ground it is final velocity. We need to find at what velocity does it reach the ground, that is final velocity v, and we also need to find the time. So we know the formula. In the last class we discussed about the formula. 3 equations we discussed. V square is equal to, so s is equals to ut plus half at square. This is one formula. And also v square minus u square is equal to 2as. This one formula, and one more formula is there. So we have to see which formula will suit this. So now if we go for the first formula, we don't have time, so we're not able to take that one. But second one they can go. Why? Because we know a. What is a? That is 10 meter per second. What is s? S is nothing but distance, that is 20 meter per 20 meter. And also we know we find a velocity v square, so you can find initial velocity. After finding that, you can use this formula, or even you can use a is equals, acceleration is equal to v minus u by t. So you can use this formula to find the time. So now we'll go for this first. Here v square minus u square is equal to 2as. V square minus u square is nothing but 0, is equal to 2 into 10 into 20. So that is 2 tens are 2 into 10, that is 200. 200 into 20, sorry, not 200. So 2 into 10 20, 20 into 20 40, that is 400. So 400 velocity is equal to 400. V square is equal to 400 actually. So here v square, which is equals to 400. What we want? We want v. V is equal to square root of 400. So square root of 400 is nothing but plus or minus 20. So I'll take here plus 20. 20 meter per second. So we got what is v, and also we need to find t. So how to find t? So we know v minus u, acceleration is equal to v minus u by t. We can simplify this. You can write here t is equals to v minus u by a. So this is acceleration. So this is time. To find time, t is equal to v minus u by a. So v is we don't know. Oh, sorry, just now we found 20. So 20 minus. So what is 20 minus? What is that? Final velocity. Initial velocity 0. 20 minus 0 is 0. So 20 divided by 10, which is equals to 2 seconds. So t is equal to v minus u, which is divided by a. That is 20 minus 0 divided by 10 is equal to 2 seconds. So time is 2 seconds, and this one final velocity is 20 meter per second. Is it clear? Okay. So next problem. So here's the next question. The speed time graph for a car is shown in the figure 8.12. So this is a speed time graph. So in the by using this graph, we need to find how far does the car travel in the first 4 seconds. See here, in the first 4 seconds, in the sense we can draw one line like this. So we can draw one line like this for the first 4 seconds. So this is a speed this is the what is that, this is a distance traveled by the car in the first 4 seconds. That is the area under the what is that, speed and time. So we can write like this. So the distance covered is nothing but area under the speed and time, speed time. So we know that what is the area under speed and time. It is almost to look like triangle, right? It not exactly look like triangle, but it's almost look like triangle. So if it's almost look like triangle, so we can consider that as a triangle. So we know what is the area of triangle. So area of triangle is nothing but half times base into height. So area of triangle is nothing but half times half into base into height, or half times base times height. Okay, so now here half constant, base here it is 4, and height is 6. So if we simplify that, we'll get 12 meters. So this is the area, this is the shaded area, represent the distance traveled is as follows. And second question, um, so second question, first question is that is find how far does the car travel in 4 seconds, and shade the area on the graph, and that represent the distance traveled by the car during this period. Write this thing in your classwork, but don't write in the graph sheet, write in the normal in your classwork only, don't want the graph. So now which part of the graph represent uniform motion of the car? So which part of uniform motion? Uniform motion in the sense the object must be traveling in a straight line. So from where it is traveling in a straight line, you may see here from around from the sixth second. So at the speed of 6 meter per second. So then this object is traveling at a uniform motion. And after 6 seconds, car moves in a uniform motion at the speed of 6 meter per second. I hope all of you understood this. Okay, next question. Okay, yeah, the next question, ninth one. State which of the following situation are possible and give an example for each of this. Which of the following situation is possible, and give an example for this. An object with a constant acceleration but with zero velocity. Okay, does it possible constant acceleration? It is possible only when the object is moving, uh, what is that, it is moving with a constant speed. There is no change in the speed, especially when we are driving vehicles in the highways. So usually where we driving the vehicles in the highways, the road is free. So once we give the accelerator around for 1 meter, around for 1 kilometer or 2 kilometer, will not decrease the accelerator, so it will not decrease the speed. So it is moving in a constant velocity. So when it is moving in a constant acceleration, then the velocity is zero. Okay, so that is possible. So but in the real situation, actually that is one of the real life situation, but one of the example, one more example is when we throw a ball upside. When you throw a ball up, so what happen, so the ball will move in a constant velocity. Okay, that is one of the example. And next one, an object moving in a certain direction with the acceleration perpendicular to the perpendicular distance direction. So for answer for this is, so first answer, so that already I told that, yes. So yes, a body can have a acceleration even when its velocity is zero. So the example for that is when a body is thrown up at highest point, its velocity is zero, but its acceleration is equal to the acceleration due to gravity. It's very simple. A person is standing here. This person, what he'll do, he'll throw the ball upside. When you throw the ball upside with some acceleration, it will move. But after moving to certain distance, it has to fall down again, right? But while falling down for a microseconds, not for micro minutes, microseconds, it may be about 0.001 second. What happened, the ball will stop, but the ball what it stopped at that point we're not able to notice it. The ball will stop at this point for a microseconds. So then the velocity become 0 after stopping for a microseconds. Then after stop only it will start coming down. So while coming down, what happened, it will fall against the gravity, that is acceleration due to gravity, that is what is it, 9.8 meter per second square. We're going to study in the higher classes. Okay, so next, an object moving in a certain direction with the acceleration is perpendicular to direction. Yes, this is also possible. So when, in the sense, an acceleration moving horizontally is acted upon by acceleration due to gravity and as vertical downward. So suppose here a table is there. When object is moving at this position, ball is moving at this point. So the ball is moving in a straight direction, but because of the acceleration due to gravity, that it is pulling down, okay, on the table. When the ball is on the table, when you push the ball moves in a straight direction, but and also it is moving in this direction, and also acceleration due to gravity, it is also pulling down the ball. So this is the condition. Okay, so next problem, and here the last question. An artificial satellite is moving in a circular orbit. So it is moving in a circular orbit like this, circular orbit, okay, of radius of this is 4250, sorry, 4000, sorry, not 4000, 42,250 kilometers. The radius of this circular orbit is 42,250 kilometers. Calculate its speed if it takes 24 hours to revolve around the earth. So what is the speed? Is revolving around, revolve the earth in 24 hours. So here they give what is the radius, sorry, the radius. So they given in the kilometers, convert to the meters. So always you should convert the distance in the terms of meters. So how to convert? So we know that 1 kilometer is equals to 1000 meters. Okay, 1000. Okay, so 1 kilometer is 1000 meters. Kilo in the sense 1000. So therefore what they did, so they converted this 42,250 kilometers into meters. So it become your this. Okay, so now time they given, so time they given in terms of hours, so convert it to the seconds. So how to the seconds? We know that in 1 hour we have 3600 seconds, or the 60 into 60, so 24 into 60 into 60. So we'll get some answer. So don't simplify that. So why? Because our simplification will become easy. So we know that speed is equals to distance traveled by time taken. We know that speed is equals to, so speed is equals to distance by time, isn't it? So here what is the distance traveled? Distance traveled is nothing but the circular path traveled by the circular path traveled by this object, or the, what is this, satellite. So what is the distance traveled by the satellite? So it's nothing but circumference of the circumference of the circle. So circumference of circle. So what is circumference of circle? We know, we learnt in your previous 8th grade. So in the mathematics, circumference is nothing but 2 pi r. So it is 2 pi r, and time is this one, 224 into 16 to 60. Now if we simplify this, if we multiply and divide this, so we'll get 3070.9 meter per second. That is nothing but 3.07 kilometer per second. So this is how we need to solve. Okay, so I hope all of you understood this. In case if you have any doubts, so please ask me through the message or call. Okay, and all of you copy this in your physics classwork. I hope all of you maintaining 200 pages physics classwork, right? 200 pages physics classwork you're maintaining. So all of you keep this. So all of you write this in your physics classwork. Okay, so then we'll see the remaining thing in the next class. Okay, so in case if you have any doubts in this problem solving or any of the questions, so please ask me through the message. Okay, okay, so then see you, then we see you in the next video. So thank you. Bye.